Solo 500 follows Solo 800 and 360 loudspeakers in utilising our adaptive bias control technology to optimally set the biasing of the output stage of the amplifier. The output stage of a Class AB amplifier is the part that's tasked with actually delivering the required power into the loudspeakers. It's made up of two sets of high-power transistors, one that handles the positive side of the signal and one that handles the negative side. The smooth handover from one to the other as the signal crosses through zero is crucial to the performance of a Class AB amplifier. To aid this smooth handover, a bias voltage is applied to the output transistors, which in turn causes a small bias current to flow through them. This current needs to be set at a very specific level in order to achieve the lowest possible distortion. However, the relationship between the applied bias voltage and the resulting bias current isn't constant. It changes significantly with the temperature of the output transistors, as well as over their lifetime. There are techniques used in conventional Class AB amplifiers that can help to correct for some of these variations, such as slow changes in temperature. However, these techniques are ineffective at correcting for things like rapid changes in temperature, which can occur from large transients in music, as well as changes in transistor characteristics over their lifetime, and variations between individual transistors. The accuracy of the correction is also likely to drift over time, and all of this means that the performance of an amplifier may degrade over its lifetime and vary between units in a single setup. With our adaptive bias control, we constantly monitor the amplifier's output current, digitize it, and then use some signal processing in the digital domain to extract the instantaneous bias current. We can then compare this to the ideal level that we're aiming for and correct for any errors in real time. This approach gets around the issues with the more conventional techniques. Both slow and rapid changes in temperature can be measured and corrected for, and changes in device characteristics over the lifetime of the amplifier will be accounted for due to the digital nature of the correction method. Also, any other potential error sources and long-term changes are dealt with by calibration routines that take place during startup. Overall, this contributes to an amplifier that will always perform optimally over its full lifetime from the moment it's turned on, and each Solo 500 in your system will perform exactly the same as the others.